Alright, to start, square root of 50, we're going to break that down into however you want. You can say 5 and 10 if you like. 25 and 2 would be better. But we'll do 5 and 10, which can go even further. Another 5 and 2. So we'll make that the square root of 5 times 2, at which point 5 comes out. We have 5 square root of 2. Okay, next. Negative 50 is going to be exactly the same, except we'll take a negative out as an I. So we'll split that up a little differently this time. We'll do negative 1. We'll do 25 this time and 2, so that you see it's a little more efficient. If you find that perfect square, the square root of negative 1 comes out as I. The square root of 25 is 5. Square root of 2 stays put. So look at how similar those two answers are, right? The next one is an exercise in multiplying. Remember that radicals can multiply other radicals and change. Coefficients can multiply. But otherwise, it just kind of smack together. So we have a 4i times 2i, or 8i squared, because I times I. And square root of 3 can't really do anything other than come along for the ride. And then we're going to do the same thing here, but this time the square root of 3 has someone to multiply. So we end up with a negative 4i square root of 3 times square root of 3. Take that a little bit further. We know that I squared is negative 1. So I have negative 8 square root of 3. I have a 4i here. And then the square root of 3 times the square root of 3. By definition, that is just 3. So our final answer, negative 8 square root of 3, subtract 12i, because the 3 and the 4 combine to make that 12. Right? Focus, focus. Okay. There we go, much better. Okay. So let's move a little further. Let's see if I can get a little bit more room here. Oh, that looks even better. So this one, you can simplify first or last. What I'm going to do, instead of using these huge numbers, I'm going to go ahead and simplify the bottom. We're going to take out a negative 1, and we're going to make that the 98. Right? And then maybe you see that, hey, 98 can split up into 49 and 2. Why are those numbers so important? 49 happens to be the perfect square of 7. So we're going to have square root of 7 on top. The negative 1 is going to turn into the I. The square root of 49 is going to turn into 7. And the square root of 2, well, it's just the square root of 2. So if only we were done. What's still wrong with this one is that it has radicals and complex on the bottom. So how do we get rid of those? That's going to be like example A in your notes. So if you need to get that out, pause it, take a look at it. Otherwise, we're going to get started. So it's those two things that we need to get rid of. This is not a conjugate problem, but rather just a matter of multiplying by a fancy 1. So if you take a look at what we get, let's see if I make enough room for myself. I have I times the square root of 14 on top. That should make sense. And on the bottom, I have 7i squared times the square root of 2 times the square root of 2, right? Because I had 2 of those. So we're going to make one last hoorah here. We have I square root 14 on top. That didn't change. We're going to simplify a couple things. I have square root of 2 times the square root of 2, which is 2. I have the 7. And I have I squared, which becomes what? Negative 1. So what is that? Negative 14. Okay? So next problem. Last one I can probably fit on this page. It's just a simple squared problem. What does it mean to square something? It means write it twice and multiply. So I can do this one really quickly. You could spend some time breaking the square root of negative 32 down, but I think that would be in vain. Or not in vain, it would just take you too long. So one of the things we can do is illustrate the property. Commutative, meaning we can change the order of things a little bit if we want, if it makes some other things more clear to us. And hopefully it does, because 2 times 2 is 4. And the square root of negative 32 times the square root of negative 32 is negative 32. So from there we simply have 4 times negative 32, or negative 128. Okay? Let's see. How many do we have? 3 to go. Make sure you can see it. Okay, so here's our first conjugate problem. Remember how that works. We're going to multiply by a chameleon or a fancy one consisting of that conjugate pair. So 3 minus square root of 2 is the original, then 3 plus square root of 2 is the conjugate that's going to help us get rid of the radicals. We'll do some quick distribution on top and get 6 plus 2 square root of 2. We'll do some foiling on the bottom. So we have 3 times 3 is 9. 3 times the square root of 2 is 3 square root of 2. 3 times the negative square root of 2 is negative 3 square root of 2. And you see why I wrote those over there. They cancel. With conjugates, that always happens. And then our last one is going to be positive square root of 2 times negative square root of 2, which is just negative 2. Or, as a simplified answer, we get 6 plus 2 square root of 2 over 7. No more radical in the bottom. That means success. Okay? 7. Again, it has a binomial or 2 terms in the bottom, so we're going to have to use the conjugation process. And it's really easy. If I minus 5 is our original denominator, then our conjugate's going to have the plus sign, and everything else stays the same. Notice the top and bottom have to stay the same. That's what makes it a chameleon one. It's still 1. So we'll distribute on top and get 5i plus 25. On the bottom, hopefully you guys have picked up this by now. When we're doing conjugates, we really only have to worry about the first 2 and the last 2, because the middle 2 are going to cancel always. So we've got I times I is I squared. Negative 5 times positive 5, negative 25. I happen to know that I squared is negative 1. So I'm going to go ahead and reorder it here. 25 plus 5i over, well, negative 1 subtract 25 is negative 26. And our final one, which I threw a bit of a curveball here, I'm going to go ahead and change that square root of negative 1 to, what is that the definition of? That is I. So here's what we're really looking at. I plus 1 divided by I minus 1. Right? All right, focus for me. Now, this last one, our conjugate, what's our conjugate going to be? I plus 1. Notice that's the opposite of the denominator. So on top I have I plus 1 times I plus 1. On the bottom I have I squared minus 1. So the easy part is, if that's negative 1, I've got negative 1 subtract 1, or negative 2. You may need to take a minute and make sure you can multiply I plus 1 times I plus 1. I squared plus I plus 1. So what is that? I squared plus 2I plus 1. That's negative 1. That's positive 1. What do those do to each other? They cancel. So I have 2I divided by negative 2, or as a final answer, 2 divided by negative 2 is negative 1. So I have negative 1I. Sorry about the focusing issues. Hopefully you were able to focus.